So I actually don't really watch this much, but you tend to use that number.
Oh yeah, this is two numbers, right? So there's a G3 and a P2, right? So the P2 is right now 18. So that's.
Trying to find the right amount to open this needle valve, so there's about 2 pounds.
Usually, how long does it take to condense all these mixtures?
I think this one's pretty fast. It's between an hour and 2, I think.
An hour.
But you can always, once you get enough condensed, you can always try to start circulating and condense at the same time too, if you want to.
Okay, true. Okay, okay.
What's more often is I just open this up until I get an equilibrium, and then just leave it for a while and let it condense. Sometimes if it's late at night, then I'll go home and start circulating in the morning. Because of course, once you start circulating, that's a big step. It takes a long time before it can start. So usually I'm starting to circulate early in the morning. So. So I'm often condensing the night before.
Okay. So actually, as long as we so do we plan to do some measurement at this 1.5K or?
I don't think so. I mean, the only thing we would do would be the same type of measurements.
Okay.
But I think we may have to come back up to this temperature again. We can see if we get the same type of stage curves. But
okay.
I was thinking tonight maybe the best thing to do is just to condense the mixture and transfer some more helium in, so we have full, so we don't have to interrupt things tomorrow. And then as soon as we start tomorrow morning, we can set up our measurements tonight and everything. Come in tomorrow morning and start circulating and take R versus T.
Okay.
And if you have another plan.
Should I go set up the
yeah, you can
measurements
go.
or
Yeah, so I mean,
setting up
I recommend. So let's see what you have in there. Okay, so we're ready to start circulating. So we're taking data while we're circulating and cooling down from. Let's see, the mixing chamber is at 1.6 Kelvin. 1K pot is at 1.5.
Yeah,
That's fine.
And
yeah,
the mixture's all condensed. So the dumps are open to the condenser and actually to the still side as well. And you can see the pressure there is about 30. It's about, I don't think it might be much lower than
32.
that. So what I'm going to do is I'm going to close off, right now this side and this side are open to each other. I'm going to close this off. So now the only opening is through the impedance in the fridge. And then I'll close out the dumps for now, and we'll later put, there's 30 millibar of stuff up in the dumps, so we'll later put that back in after we start circulating. So to start circulating, I just start opening up this valve number 6. And so the path is just your main circulation path. So the pumping is still sending the back of the pump through the traps, sending it back to the condenser. And this valve here only starts opening once it gets to about 8 or 9. I can't remember what percentage it is.
It's written 12%.
Oh, is it? I thought it's 1% when
When to start opening.
start opening.
Yeah.
So it probably hasn't started opening yet. The temperature is not dropping. But once it gets to where it starts opening, it's pretty sensitive in there.
Right, like 11.8 something.
You can also look at the pressure starting to go up here, so I can see that it must be starting to pump. Now you can see the pressure is at 1.65 or 1.65 before it stopped now. 1.63.
So initially we opened it just slightly, right?
So there are different methods for starting the circulation, and the manual says that you should keep this below this pressure here below 200, I think.
Yeah, G1 below 200.
G2 below 200, or is it G1?
G1, because G1 goes to the condenser line, right? G2 is
these will roughly be the same. I mean, there's always be some pressure.
unless you control the valve, the valve control the nitrogen trap, right, in front of it. There's
So I think John's method is to use. We have another needle valve here that you can control how much you're actually putting back down to the condenser, and that's an extra depot down there. My method is to ignore what the manual says and just keep opening this and pumping and not worry too much about this back pressure. I think the only danger, well, there's two dangers. One is you don't want this to get really high. If it gets high enough, this relief valve will go back to the dumps. But the other is if you circulate too fast, maybe the mixture doesn't go through the traps enough. But I don't think that's, so far for me, that hasn't been a problem. So this is my preferred method. So usually what I'll do is I'll just watch the temperature, and eventually the temperature can sort of stall at some position. So it's sort of stuck on 1.56 there. So I'll open that a little bit more and see if I can get to start dropping. And so now it's started dropping, and I'll just wait, and it'll keep dropping until at some point it hits these cycles above sort of mainly above 1 Kelvin, where it can get kind of stuck. So my method for getting it unstuck is just to keep opening that a little bit more. And this pressure, so now it's going above 200 now. I think it might go as high as 400 or 500, but before it eventually starts coming down.
What's pumping into the condenser? Is that the pump right there, or is that?
You're asking about what's pumping here?
What essentially is forcing the condenser? Is that pressure right there? Right?
Yeah. So this is the back of the pump, right? It's just pumping that helium gas out of the still,
I see.
sending it through these traps here, and then just the gas is just going back in there. But yeah, I mean the actual pressure in the condenser itself is going to be lower than this, and this is just as long as there's some pressure there. I mean,
okay. That pressure is just created by the pump, though. It's the back pressure. It's the pressure of the back of the pump.
Yeah, it's the pressure of the back of the pump, and also the fact that gas is warmed up, so that's going to expand a little bit. I mean, remember that if it's just liquid in there, we have pressure of like 30 millibars. So as long as it's circulating, we'll always when we get this
well,
going.
If it's liquid in, okay.